Time to complicate things a bit. Let's see what happens when we have multiple functional groups present in the same organic molecule. And let's go through the procedure of naming such a molecule. The first thing that I need to tell you about is that there is an actual priority for functional groups. I'm going to show you the almost complete list, which incorporates all of the molecules, even the ones that we're not necessarily going to talk about nomenclature in this class. But the family group to the left, or further to the left, has a lower priority than groups that happen to be to the right side of the list. And you could, if you want, try to come up with some mnemonic or maybe a song that gives you the order of these things. But I personally think that it's better to just look at the corresponding oxidation states. And what you will observe is that for your typical ether molecule, if you stick to the smaller molecules, like this one that contains only 2 carbons, 1 oxygen, you have an oxidation state on that carbon of -2. An alkene has, and the simplest alkene, right? So this is your 2 carbon chain, has also a similar value of -2 for the oxidation state. The alkyne, on the other hand, has a value that is 1 charge higher, so -1 instead of -2. For alcohols, if you look at the carbon where the alcohol is bound, that could also be -1. It could even be greater than that value depending on how many carbons are bound in this position. Your ketone has, generally speaking, a +2 charge on the carbonyl carbon. Aldehydes, generally speaking, a +1. Nitriles +3. Amides +3 on the carbonyl, so does the ester, so does the carboxylic acid. So generally speaking, with maybe a little caveat here and there, but generally speaking, the order of priority is based on the oxidation state of that carbon, the carbon where the functional group is located. And the higher the positive charge, or the more positive the charge becomes, the higher the priority. And in the case of amides, esters, and carboxylic acids, that when you get to that portion of your studies in organic chemistry, you probably need to memorize that order, because they all have the same type of oxidation state. Perhaps the one thing you could say though is that the oxidation state of the carboxylic acid and the ester are probably going to be higher in terms of the delta plus that they generate, because oxygen is more electronegative than nitrogen. So even though they're all threes, probably this is more like a 2.7, whereas this is more like a 2.9, right? And then this is more like a 3, that kind of thing. But the oxidation state kind of helps you in this sense. Now, the priority within the context of naming is simply going to tell you that the higher priority functional group has to have the lowest numerical value in the name. So you're looking to give that higher priority group a lower value. So we'll see how this plays out. Here's an example. We have an alkyne, we have an alkene, and we have an alcohol functionality. We have 3 functionalities in this molecule. In order to name it, we first identify how many carbons there are in the chain. And we're going to try to give the lowest number to the priority group. Alright, so counting the carbons going from this end to that end, we have a total of 8 carbons in the entire molecule. And be sure to count the carbons that are making up that triple bond, right? There's 2 carbons making up that bond, so don't forget to count them. Okay, so this is what we have. Based on this numbering, the alkene appears first at position 2, the alcohol appears first at position 5, and the alkyne appears first at position 6. Now altogether there's 4 carbons, so they should be known as octa something. Now notice that here I'm separating the prefix from what's about to come, because we're going to have some numbers that will tell us where the alkene, the alkyne, and the alcohol are located. So as I said, the alkene appears first at position 2, the alcohol at position 5, and the alkyne at position 6. And I'm going to arrange them alphabetically. Sometimes you can see in the literature that the alcohol is given priority even in the order, but I'm going to go with alphabetical order for this example. All right, and here we need to remember the suffix for each one of those. Alkenes go with in, alcohols go technically with anol, and alkynes go with ein, right? So alphabetically, you place the alkene first, then the alcohol, then the alkyne. Now notice that instead of writing anol for the alcohol, here it's just sufficient to just write OL. And notice that the numbers appear before the corresponding functional group, right? So kingdom position 2, you have the 2 hyphen in, 5 hyphen O, hyphen 6 hyphen ein, right? So you separate the numbers from letters using hyphens, and the number always precedes the functional group that the number is associated with. All right, so that's if we count from 1 to 8 in the red series. Let's see what happens if we go the opposite end or the opposite way. We are going to go now in the blue series, right? So 1 to 8. This time around, the alkyne appears at position 2. The alcohol appears at position 4, and the alkene appears at position 6. So this is how the numbers would change. Now, out of the two, the one that's correct is the one that gives the preference and the priority to the highest priority group, which between these three, it will be the alcohol. The alcohol is the one that bears the highest priority. Therefore, you want to give the alcohol the lowest value, which means that the one that gives you all the preferences and all the correct assignments is the one in blue, right? That's the one with the lowest value for the alcohol. So that's the actual name. If you select the name on top, technically you will be able to draw the molecule from this description, but the description in terms of the name is totally wrong. You selected the wrong number for the highest priority group. Okay, here goes another example, a little bit more complicated. Here, counting from one carbon end to the other, we have a total of 12 carbons, as you can see here, all numbered. We have alkenes, we have alkynes, and we have alcohols, right? So we have alkenes, oh, we have all kinds of trouble here, but no problem. We're gonna go through it. I'll help you go through it. Okay, so going in this red series from 1 to 12, the alkynes appear first at position 3 and at position 9. The alkenes appear first at positions 5, 7, and 11, and the alcohol appears at position 2. Going the opposite way, in the blue series, the alkenes appear first at positions 1, 5, and 7, whereas the alkyne appears first at position 3 and 9, whereas the alcohol now is at position 11. So if we were to name this molecule, first of all, we have 12 carbons in the chain. So we're dealing with dodec for the prefix. And counting the number of things we have here, so we have a total of 3 alkenes at positions 1, 5, and 7. If we go with the blue series, we have 2 alkynes at positions 3 and 9 in the blue series, and 1 alcohol. Right, and the red series is 5, 7, and 11 for the alkene series, 3 and 9 for the alkyne, and 2 for the alcohol. Now, without even writing out the entire name, you can kind of tell, okay, well, between the alkene, the alkyne, and the alcohol is the highest priority group. So you want to make sure that the alcohol has the lowest value. And between the red series and the blue series, 2 versus 11, 2 is the lowest value. So the red series is the proper way of naming this molecule. And the way we do this is, once again, alphabetically. In first, O second, and ein last. So you do not take into account the prefixes for the values, like how many of them you have. It's just the alkene, the ol, the ein that you count alphabetically. They all appear, of course, at the end of the prefix. So dodeca appears first, and then you have all of this. Now notice that for the alkene, positions 5, 7, and 11, you separate them by comma. So you have 5, 7, 11, hyphen. And instead of saying in, we just depict the fact that we have 3 alkenes at those 3 positions by using the prefix tri. So triene, and this is the typical prefix that you've seen in general chemistry, right? So now we apply it to the alkene, so triene. And the alcohol, there's only one, so you just have to say 2-ol. Then you have 3,9 for the two alkynes, and since there's two alkynes, you use the prefix di, so diene. Altogether, the name of the molecule will be dodeca 5,7,11 triene 2-ol 3,9 diene. Right, and if you go with the blue series, you'll get marked down because unfortunately the alcohol has the highest value in this setup. So you do not want to go with the blue series. It's all about the red series in this example. Okay, now I'm going to make one tiny little change just to show you what happens. And I want to show you this one more time. Okay, so the red series is the one that won because of the alcohol. Let's remove the alcohol and see if that is true still. So here we only have alkenes and alkynes. And the numbering, of course, is still the same. It's the same molecule. All we did is just remove the alcohol. So we have the 5, 7, 11 for the alkenes, the 3 and the 9 for the alkynes, 1, 5, 7 for the alkenes, 3, 9 for the alkynes. So you will have the following names: dodeca, 5,7, 11 triene, 3,9 diene in the red series, and dodeca 1, 5, 7 triene, 3,9 diene for the blue series. Now here the question becomes, well, which one is the correct one, right? The alkene and the alkyne are kind of roughly in the same group, but here when this happens, where you only have alkenes and alkynes, you're gonna give priority to the alkene. And I'll be honest with you, to me this seems like a very arbitrary decision on the part of the functional groups. In my opinion, it should be the alkyne, but no, the alkene is the one that takes priority if all you have is alkenes and alkynes. So you end up giving the lowest number to the alkene. So instead of 5, 7, 11 for the alkenes, you go with 1, 5, 7. So here you actually stick with the blue series. Once again, this is only exclusive to molecules where there's only alkenes and alkynes. And by the way, you don't need to have multiple alkenes and alkynes. You could only have one alkyne in the molecule and one alkene in the same molecule. You still give preference to the alkene. Alright, so with all that being said, I'll stop the video right here, and on the next video we'll talk about substituents. This is where we get to branch out from the main parent organic chain. So see you in the next video.